Famous networks such as the AlphaGo or AlphaZero networks, that for instance the AlphaGo was the one that was that beat the Go players. So Go is a game similar to chess. So they use something. They use reinforcement learning, but coupled to this Monte Carlo tree search. So Monte Carlo tree search, somehow it can be seen as a search algorithm that can be used in reinforcement learning, and it somehow explores or exploits. No, it balances this exploration versus exploitation trade-off. So, given the current state and a number of steps that we want to go ahead, the output will be, given this state, what is the best policy that we can follow. So here we are showing an example, a very simple example with tic-tac-toe. So let's say that this is the current state. So now from this current state, we can explore, for instance, putting a cross in this point, in this point, or in this point. If we put a cross in this point, we have 1. So we have a reward of plus 10. If we put it there, then there could be a circle there, which is minus 10, or there could be a circle there, which is not finished yet. And then we have only one position left for the cross, that would be this one, that is plus 0. And so we explore from the current state, we explore a little bit the next states further. So somehow it is can be represented in this way. So we select a node, we select an action from that node, then we expand it. So we expand that branch, we simulate that branch. So given this state, we go further, and then we backpropagate. So given the rewards that we have at the end, we backpropagate those rewards towards the current state, and then this is repeated many times. So starting from the root node, so the current state S, the Monte Carlo tree search chooses an action to traverse the tree based on an exploration-exploitation strategy. We saw the epsilon greedy before, so now it is not epsilon greedy. Somehow this epsilon, that was the balance between exploration and exploitation, is now somehow played by C. So we have a number of variables here, that is the cumulative reward, that is how much reward we have observed so far for action I. This would be a kind of equivalent to the Q value. Then we have NI, that is how many times we have visited this action, and N, that is how many visits we have done to the parent state. And so this term is somehow an empirical average of the reward taking this action, and this term somehow promotes the actions that haven't been tried so far, so or so often at least. So this one is the exploration, this one is related to the current reward. So for each action we calculate this thing, this is called the upper confidence bound, and then we choose randomly among all possibilities according with the probability that is somehow related to this upper confidence bound. So that is for the selection, so which action to do. Then we have to expand Then the expand is we add a new node that is the resulting state S prime, and then we simulate from there. So we choose an action. So we choose an action. We have a new state. Then we simulate from there, and we will back propagate. So we simulate from there, and then we will back propagate. So we will simulate until we reach a terminal state. So for instance here, these two states are not terminal. This state is terminal. So we simulate the different paths until we reach a terminal state. And then once we have a terminal state, we will have a reward. And then this reward is back propagated. So this R here, that is the reward that we have obtained, it is back propagated through all the nodes in the path. So we update the reward of taking action I. So the reward of taking action I, and we update also the number of times we have taken action I. And here is a picture taken from the AlphaGo architecture. So again, we will not see the details, but somehow we see that we have the same kind of ingredients. So these ingredients we have states, we have actions, and then these actions will have rewards. So the neural network comes in the evaluation of what we think is the value of that state, and what is the policy that we should, given this state and given given this state, what is the best action that we can perform, and the value given this state and given this action, what is the expected reward that we will get. So again, all the details, they can be rather complicated. We will not see all these details, but we get an idea of where the neural network comes in.